Welcome to this demonstration of Replay. Replay is a local-first software evolution explorer that helps developers understand how a Git repository has evolved over time. Instead of simply listing commits, Replay reconstructs the project's history commit by commit, analyzes every version of the code, and visualizes changes in architecture, complexity, maintainability, and overall code health. Everything runs completely on your local machine, with no cloud services, API keys, or large language models required. Let's see it in action. Repository import. When Replay starts, the dashboard is empty. To analyze a project, I can either choose a Git repository already available on my computer or provide the URL of a public GitHub repository. For this demonstration, I'll use the repository AI agent honeypot check. Once I click Analyze Repository, Replay begins processing the commit history. Behind the scenes, it checks out every commit in chronological order, analyzes each Python file, calculates engineering metrics, and stores the results as historical snapshots. Once the process finishes, Replay reports the total number of commits that were successfully analyzed. Pause for 2 seconds while showing the completed analysis. Overview. The Overview dashboard provides a quick summary of the repository's current engineering state. The first metric is the health score. This combines maintainability with technical debt to provide an overall indication of software quality. Higher values represent cleaner and healthier code. Next is complexity. This represents the total cyclomatic complexity across the project. As software grows, complexity naturally increases, but sudden spikes often indicate areas that deserve attention. The third metric is maintainability. Replay calculates the maintainability index for every Python file and averages the results. Higher values indicate code that is easier to understand, modify, and extend. Finally, we have technical debt. Replay estimates technical debt by identifying files whose complexity exceeds healthy thresholds. Lower values indicate a cleaner and more maintainable project. Each metric also includes a trend indicator showing how it changed compared with the previous commit. Health trend. Below the summary cards is the health trend graph. This chart visualizes how the overall health of the repository changed throughout its lifetime. Notice that dips in the graph often correspond to commits where complexity increased faster than maintainability. This makes it easy to identify periods where code quality declined. Timeline. The timeline is the heart of Replay. Every analyzed commit appears here with its hash, author, message, and date. Selecting any commit instantly updates every visualization in the application. Rather than viewing only the latest version of a repository, Replay lets us inspect the project exactly as it existed at any point in its history. Architecture. The architecture view displays the project's internal module structure. Each node represents a Python module, while each connection represents an import relationship. As different commits are selected, this diagram evolves, allowing us to observe how the software architecture expanded over time. Dependencies. The dependency view focuses on relationships between modules. Replay automatically detects circular dependencies, which can make software difficult to maintain and test. If cycles exist, Replay highlights them immediately. If no cycles are detected, it confirms that the dependency graph remains clean. Hotspots. The Hotspots view identifies the files that contribute the most complexity to the project. Files are ranked by complexity while also displaying their maintainability score and line count. This helps developers immediately identify which files are the strongest candidates for refactoring. Compare. One of Replay's most useful capabilities is repository comparison. Here, I can select any 2 commits from the repository's history. Replay then calculates the exact change in metrics such as lines of code, functions, complexity, maintainability, technical debt, and health score. This makes it easy to measure the engineering impact of any feature, release, or development period. Reports. Finally, Replay allows all analysis results to be exported. Developers can preview the raw JSON data or generate comprehensive Markdown and PDF reports. These reports summarize the repository's engineering metrics and can easily be shared with teammates or included in technical documentation. Closing Replay transforms a Git repository into an interactive engineering timeline. Rather than showing only what the code looks like today, it reveals how the software evolved over time, highlighting architectural changes, increasing complexity, technical debt, and overall code health. By making software evolution visible, Replay helps developers better understand, maintain, and improve their projects. Thank you for watching.